Hello everyone, in this video we're going to see the solution to the Codeforces problem B accurately, which is the problem B of Codeforces round 652 division 2. Okay, so in this problem we're given that we have a binary string of length n, the string is s, and so the string is binary, meaning that the string will consist of either only 0 or only 1. Okay, now what we have to do is we have to make the string as clean as possible. Now what does clean mean here? Okay, so if two strings are there, then the shorter one is cleaner, and if they're the same length, then the lexicographically smaller one is cleaner, meaning that we have to shorten the length of our string and then we want to make it lexicographically smaller. Okay, and what operation do we have for doing that? So the operation is that if at any point if s of I is 1 and of s of I plus 1 is 0, then we can erase exactly one of them. Now, do remember that if we have 1 and then we have 0, only then we can remove exactly one of them. If 0 and 1 is there, we cannot do that. Okay, if we have 1 and right after 1 we have 0, then we can erase either one of them. Now, let's look at some test cases. So, here you can see that this is one test case. So, I'll just copy this and okay. So, this is one test case. Now, it says that if we have 1 and then we have 0, then what we can do is we can remove either the 1 or the 0. But you can see that here we have 0 and then we have 1. Okay, we don't have any 0 after any 1. So in this case, well, the string will stay as it is, so the answer will stay as it is, right? Because, well, we cannot do any operation, right? Now let's look at the next example. Okay, so this is 0101 and this is just the length of the string. Okay, so this is 0101. Let's look at this. Okay, so it said that when we have a 1 and then we have a 0, we can either remove the 1 or the 0. Okay, so I come at this point and I see that I have a 1. Right after that I have a 0. Now I can either remove the 1 or the 0. So suppose I remove the 0. So I'll get the answer 0, 1, 1. And now I cannot do anything, right? Because we don't have any 0 after 1. But is this the best I could have done? No, because this was my string earlier and I got that there's a 0 after a 1. Now I can either remove the 0 or the 1. So like I said, it's given in this question that if two strings are having the same length, the lexicographically smaller one is the better option. So in 011 and 001, 001 is the better option. So in between these two, we can remove the this one. Okay. So for this, answer will be 001. So our problem was for this, it was 010101, and for that the answer came out to be 001. Okay, now let's look at another example, then we'll see some generic test cases and then we'll try to formulate it. Okay, so okay, this is one more problem, 11001101. Okay, so this is our next question. Okay, now this is the turning point test case. Okay, because right now we just simply saw that we have a 1 and 0 and it is better to remove the 1. So simple, these two were just simple test cases. Okay, so this is like the main test case. Okay, so I come at this point and I see a 1 and a 0. Okay, so I can remove this 1, no problem. Now I move and I see a 1 and a 0. I can remove this one. Okay, now again I see a 1 and a 0, so I remove this one. Okay, so that I can remove. Now I'm left with this. Now can I do more operations? Yes, I can, and I want to make it as small as possible, as short as possible. So let's look here. I have a 1 and a 0, and with our logic till now, what we were doing, we were removing the 1. So I remove the 1, and this is what I get. But again, is this the best we could have done? So if you see in the example, the answer is 0, 1. Okay, so obviously this is wrong because we're getting a shorter answer. So this was the problem. Now here I can see that I have a 1 and a 0. Now if you may think that it is better to remove 1, but think of removing 0 here. So I remove 0 here. Okay, now again I get a chance to remove this 0 because again I have a 1 and 0. Now again I have a 1 and 0. Again, instead of removing the 1, remove this 0. Again I have a 1 and 0, and now there are no final zeros. So now what you should do is now you should remove that one. So now I remove that one and I get the lexicographically smallest string and the shortest string that I could have got, and that is what is there in the answer, right? And likewise, this is also a helping test case which can help you get make like generalize it. So look at this test case. Okay, so at this test case you can see that we have ones and we have zeros, right? Like this is just the opposite of this, right? Now here the answer is coming out to be 0. And how is that? Let's look at that again. Okay, so I get this 1 and a 0. So here I can remove anything, doesn't matter. Let's remove the 1. Again I have a 1 and a 0. Let's remove the 1. And now let's do that thing. Okay, remove a 0. Then again we have 1 and 0. So we'll remove the 0. Again we'll have 1 and 0. So I remove the 0. Again I have a 1 and 0. I'll remove the 0. Again I have a 1 and 0. I'll remove the 0. Again I have a 1 and 0. I'll remove the 0. Now I have a 1 and a 0. And I want the lexicographically shortest string possible. So I remove the 1. And this is what my answer came to be. Okay, now let's try to generalize it. Okay, so what was our answer what was our problem initially? So this test case is pretty much done. Like obviously there's nothing to do because we have zeros and then we have 1, so we cannot do anything, right? So let's look at this test case, 0 1 0 1. Now I say that as long as you have a 1, just like focus on this. Okay, as long as we have a 1 and we have a 0, we can remove anything in between. Okay, so if I have a 1 and I have dot 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 anything, doesn't matter, and I have a 0, so I can remove everything in between up till this 1. Okay, now that is the main thing that we need to focus on. Now how is that true? So these dot can be 0 or 1, right? So if they're 1 and 0, we can remove them directly, and at last it would come to be this because we removed everything in between, and we'll remove this. Okay, so that is the point. So if it comes to be in this form, so I'll write it. If we have a 1, if we have a 1 on left hand side, okay, and a 0 on right hand side, then we can remove everything in between. We can remove everything in between, and that's all. As soon as you get that, you can just work on the answer. So we'll see if that is working on the test cases or not. So let's take this test case. So we have 0 1 0 1. So meaning that find the leftmost one, find the leftmost one, find the rightmost 0, and again there will be some corner test cases that you have to write extra code for. I'll also show you my code and give a link to it in the description. Okay, so we find the leftmost one and we find the rightmost 0, and then remove everything in between including the 1, excluding the 0. Remove everything in between including the 1, including the 1, and excluding 0, including 1, excluding 0. Now let's look at that. So I'll just, here we go. So this is my test case. So the leftmost 1 is this, the rightmost 0 is this, so I can remove this, and that is my answer. Correct. Now let's try this test case. Okay, so let's try another test case. So I have this test case. I'll just copy it and see if our logic is still working. Okay, so for that we saw that it was working. Now this is the problem. I'll just copy it again and I'll solve it with below it. Okay, now like I said, find the leftmost one. What is the leftmost one? Leftmost one is this itself. Find the rightmost 0. The rightmost 0 is this itself. I can remove everything in between like I said, and the answer is coming out to be 0 1. Now is the answer 0 1? Yes, the answer is 0 1. Now let's look at this. So this is another test case. Now find the leftmost one, this, find the rightmost 0, this, and remove everything in between including the 1, excluding the 0. Boom, this is the answer. Okay, and this is the answer which is there in the test case. And for 1 the answer will be 1. Now there is one, we can say there is one corner case. Okay, and the corner case is that itself. If we have 0 0 0, we have 1 1 1 1 1. What will be the answer in this according to us? So okay, so according to us we can say that the leftmost one is this, the rightmost 0 is this, so there's nothing in between, so we cannot remove that, right? So this if you like the code I wrote initially, so it was giving like different answer for this. So if you're using another method, basically what we're doing stays the same. The rightmost is here, and sorry, the leftmost is here 1 and the rightmost 0 is here, so you can see that their directions have changed, right? And there's nothing in between, so we have to make sure of that so that we deal with that correctly. Okay, so that is the like idea. So we can remove everything in between as long as we have a 1 on the left hand side and a 0 on the right hand side. And again, how did we get the idea for that? It's simple. If I have a 1, first of all, there should be a 0 after 1, right? So suppose it is something like 1 0 1 0 0 0 1 0 0. Okay, as long as there's a 1 and a 0, I can remove the 1. So initially I remove all the 1, keeping the 1 on the leftmost side. Okay, we can remove all this, and then like I said, we can simply do this: 1 and a 0, remove the 0, 1 and a 0, remove the 0, 1 and a 0, remove the 0. Finally, when only one 0 is left, I just remove that one and I'll get the answer. That is basically removing everything in between when there's a left, when there's a 1 on the left hand side and there's a 0 on the right hand side. Okay, so I'll just show you guys my code quickly. So okay, so this is my code and it got accepted. The pre-tests were passed. I just hope it doesn't fail system testing. Last time my B failed system testing and it was really bad because of one silly mistake. Okay, so this is the main code. So like I said, if s of I is equal to 1, k is equal to I, break. Why break? Because we want the leftmost one. So again, we want the leftmost one and the rightmost 0, right? So the leftmost one I got, and till then I'm putting everything in my answer. Why? Because everything before the leftmost one will not be removed, right? It will be in our answer. And then if k is equal to -1, I'm putting s there itself, meaning that if there are no 1, then you can just say the answer will be the same, right? Otherwise, I'm coming from the backwards and I'm finding the rightmost 0, and I'm calling that last 0. So I'm finding the index of the last 0. Okay, now if last 0 is not equal to -1, only then our answer will change, because if last 0 is -1, meaning that we didn't find any 0, so the answer will stay as it is, meaning that the string cannot be shortened anymore. Okay, now like I said, the 0 0 0 1 1 1 case, I've handled that here. If k is equal to last 0 plus 1, then I've done last 0 plus plus, or I could have simply just printed the same string again, it doesn't matter. And then finally, from last 0 onwards, like I said, I don't want anything in between, right? So I take everything. So what I'm doing is, I'm taking in this loop, I'm taking everything on the left of the leftmost one, and here I'm taking everything on the right of the rightmost 0. And then finally, answer is the string in which I keep on adding the characters which I want, and then I print answer. And these two test cases are simply, if there is no 1, then answer will stay same. If there are no 0, the answer will stay same. And one more corner case, if there is 0 0 0 1 1 1 1, then again the answer will stay the same. So that's all guys. Thank you.